Welcome back to Lesson 16. This is the second video for today, and in this session we'll focus on the planning task of the solution implementation phase. When I was discussing the planning for action task of the solution implementation phase earlier, I mentioned that implementing the solution is equivalent to a project, and that's how we're going to treat it. A project is defined as a temporary endeavor undertaken to create a unique product, service, or result. Our unique result is putting the specific solution decision into action. Once that result is complete, our project will be complete. Fortunately, there are skills, tools, and techniques that have been shown to be best practices in meeting project objectives. These form the body of knowledge known as project management. In industry, the field of project management has been recognized as of such importance that there is a professional certification in project management, the PMP. And project management can be a career field in itself. We obviously only have time in this course to give you a brief overview of some of the tools and techniques available, but the Systems Engineering Department does offer a whole course in project management, EM 411, that provides the opportunity to go into more depth. We typically think of projects as having three direct goals: cost, schedule, and performance. We want to make sure that we stay within the budget for resources, that we meet the milestones in the schedule, and that we achieve the stated objectives of the project at the expected level of quality. These three goals of cost, schedule, and performance should look familiar to you. They are three of the types of risk that we attempt to identify in the decision-making phase. The Devil's Triangle shown here represents the challenge that balancing these three goals can present. There's an old saying that everybody wants things good, cheap, and fast, but you only get two out of the three. Something that's good and cheap won't be done fast. Something that's good and fast won't be cheap. And something that's fast and cheap won't be any good. So you see that there's a tension between the three goals, and that tension may lead to some difficult situations at different points over the course of the project's life. In facing those difficult situations, the systems engineer and other members of the project management team have an obligation to act ethically. The Code of Ethics from the Project Management Institute lays out 4 values that the global project management community decided were most important in guiding their actions and their decision-making. These values are responsibility, respect, fairness, and honesty. Responsibility involves owning our actions, our decisions, and any consequences that result from them. Respect includes the proper regard for self and others, as well as stewardship of resources, and respecting the trust that we have as decision makers and managers. Fairness should characterize our decisions and interactions, and we should be transparent with our interests and relationships. Finally, we strive to be honest in words and actions and do not condone deception. With that understanding of ethical expectations of project managers, we turn to the work of project managers and the task of project planning. Good project planning sets the conditions for the overall success of the solution implementation phase. Here are 5 project management tools which have proven to contribute to successful projects. The project charter is a document issued by the project initiator or sponsor that formally authorizes the existence of the project and gives the project manager the authority to apply organizational resources to project activities. The work breakdown structure clearly lays out the tasks or deliverables of the project. The linear responsibility chart aligns people or teams with tasks or deliverables. Resource allocation is just what it sounds like: allocating money or other resources to the teams responsible for different tasks in the project. Finally, the risk management plan tells how you will handle risk throughout the project. It should include how the project team will identify and assess risk, who specifically is responsible for doing it, and how often will they meet to reassess and mitigate risks using one or more of the mitigation techniques: avoid, reduce, transfer, or accept. Let's explore some of these tools in a little more depth. First, the project charter. What's a charter? We typically think of a charter as something written by a governing authority which founds a body, such as a company, city, or college, and defines its rights and privileges. Along those lines, you can think of a project charter as a combination of 1. The authorization to perform the project and commit resources in the process of doing so, and 2. A kind of informal constitution for the project team. You can see the components of a charter listed on the right. First, who is the project for and who is on the team? The leadership plan clearly lays out who has the different leadership roles and responsibilities. A clearly defined problem statement is essential, and having agreement on the problem statement between the sponsor and the company performing the project is especially important to define the scope of the project and prevent what we call scope creep, which is where the sponsor may push for additional products or services which are outside the original problem statement. The charter also provides constraints for the project schedule through milestones and key dates. The knowledge management plan is one of the more important parts of the charter in terms of impacting project performance. It lays out standards and expectations for documentation, communication, and record keeping. Standardizing how the team will name files, where they will store them, and how the file directory will be structured will pay huge dividends in terms of efficiency in compiling project documents later in the project cycle, especially for large and longer-term projects. The meeting plan lays out the when, where, and why for recurring meetings of different teams internal to the project so that they are coordinated and deconflicted. The plan for consultation with sponsors performs a similar function for external meetings with the project sponsors. Finally, an organizational chart can be especially helpful for large, complex projects. These are some of the most important components of a project charter. Not all of these will be present in every charter, and other items may be added in order to tailor the charter to the situation of a specific project. The next tool that we'll discuss is the work breakdown structure, and you'll recall that one of today's objectives is that you need to be able to develop a work breakdown structure for a project. The purpose of the work breakdown structure is to know what needs to be done in order to complete the project. It is a depiction of the scope of work so that there is a common understanding between the project team and the stakeholders of what the outcomes or deliverables of the project will be. The WBS is shown as a hierarchy that decomposes the project. There are two approaches to a WBS. One is what I'll call the task-based approach, which is how our textbook describes a WBS, a hierarchical representation of all the tasks that must be accomplished to successfully complete a project. The other approach is what I call the deliverable-based approach, which is how the Project Management Institute describes a WBS. This approach decomposes the project into more and more detail of what products the project will produce, which when combined will accomplish the project objectives and create the required deliverables. Both approaches are valid, but they differ in what we show in the hierarchy in the WBS. Before we get to some examples of work breakdown structures, let's take a look at some suggestions for how to make them. First, we use a hierarchy structure with the top level being the project objective or objectives. Then we begin to decompose the objective into its necessary parts. What activities are necessary to achieve the project objectives? What tasks are necessary to perform each of the activities? Are there subtasks needed to clearly describe the tasks? The decomposing should be done in collaboration with those who will be producing the deliverables involved. One of the questions that invariably comes up when creating a WBS is, how far do I break things down? Remember that the purpose of the WBS is to ensure everybody has a common understanding about the project. So you'll want to include enough detail to ensure that there is no misunderstanding about what is or is not included. Never make assumptions that stakeholders will naturally know that a deliverable element or task is part of the project if it isn't included in the WBS. If in doubt, include it. As you decompose, you should follow the 100% rule. The 100% rule says that when you decompose a deliverable or task in the WBS, that next level needs to contain all of the elements needed to make up 100% of the parent element. Nothing should be left out or assumed. A few additional suggestions from the textbook are also good practices. When looking at a task or deliverable, if the team cannot determine who is responsible or how long it will take, then the task should be decomposed further. This will be particularly helpful when you create the linear responsibility chart that connects tasks with members of the team and assigns responsibility. Next, if something consumes resources or takes time, it should be in the WBS. Remember that cost and schedule are direct goals of the project, so if a task or deliverable impacts them, it needs to be included. Finally, similar to the 100% rule, the time to complete any activity is the sum of critical subtask durations. Tomorrow we'll see some tools that can help us to identify these critical tasks in the project. Now let's walk through a couple of examples of work breakdown structures. The first example is the deliverable-based approach. In this approach, each block contains a deliverable. You'll see that they are all nouns to keep focus on what is being produced or delivered. For this example, the objective of the project is to produce a mountain bike. That's the final deliverable. Next, we begin to decompose it into the major parts, asking the question, what needs to be produced in order to deliver the mountain bike? At the first level, we see distinct deliverables that when combined will create a mountain bike. The frame set, the braking system, the crank set, the wheels, the shifting system, and then we have project integration. Project integration isn't necessarily a component of the bike, but it is a vital part of the project. If this integration isn't delivered, then the different subsystems won't be coordinated, and we won't have someone concerned with the entire production system. You might think of this as the subsystem level of decomposition. Next, we decompose each of the subsystems into components or further subsystems. The frame set is made up of a frame, a fork, a handlebar, and a seat. The braking system, crank set, and the shifting system all have their components listed. You can see that we differentiate between the front wheel and the rear wheel since they are constructed differently. And we see the deliverables that make up project integration: prototype approval, production test, quality sign-off, and project management. And then we decompose the front wheel and rear wheel further to show what will be produced to create each of them: spokes, tires, air tubes, and in the case of the rear wheel, gears. Again, notice that each box has a noun, a thing that will be produced or accomplished in the deliverable-based approach. Contrast that with the task-based approach, which we'll use in the next example. In this example, our project is to produce a new appliance. Notice that the objective is phrased in terms of a task to be accomplished and includes a verb. You might be asking what the appliance shown here is. It's actually a refrigerator designed specifically for customers who are in wheelchairs. So there could be a need to take an existing product and modify it to meet the particular needs of a portion of the overall population. Here we've taken the overall objective and decomposed it into the activities that must take place from start to finish. Each activity is phrased as a task that must be accomplished: determine the product specifications, generate concepts, perform embodiment design, perform detail design, and produce the appliance. Since these activities are not sufficiently clear and may be a bit ambiguous, we need to decompose each of them further. Now you can see the different tasks that make up the 5 top-level activities, and there's additional fidelity to what the project will entail. Every task is an action that must be completed, and the WBS takes us from identifying customer needs in the top left all the way to ramping up to full production in the bottom right. Further decomposition may be necessary for clarity, but in the interest of time and space on a slide, we'll stop here. Note that for large, complex projects, it would be not just allowable, but expected that the work breakdown structure would take up multiple pages or slides. The next tool that you should be familiar with is the linear responsibility chart. Another name for this tool is the responsibility assignment matrix. This chart is used in conjunction with the work breakdown structure, and you don't actually have to be finished with the WBS in order to start the linear responsibility chart. Tasks on the WBS will translate directly over, and an individual or team within the organization performing the project gets assigned responsibility for each task. The chart also highlights other critical interactions besides responsibility, such as approval, notification, or consultation. This can help project managers identify areas or tasks that require special attention due to the number of people or teams that are involved. Here's an example of a linear responsibility chart from your textbook. The labels across the top represent the different departments in the organization or key individuals. Down the left side, you see the tasks. These are taken directly from the work breakdown structure. Then, in the matrix portion of the chart, there are responsibility codes that tell what type of responsibility or action corresponds to the person or team listed for the given tasks. The legend at the bottom tells what these codes mean. Note that it is possible for a person to have multiple responsibilities for a given task, as shown by several cells having 2 numbers in them. It's also okay for cells to be empty if a person or team has no responsibility for a given task. In this linear responsibility chart, if we look at the first task, Establish Project Plan, we can see that the land planner and the planning team are responsible for that task by the ones that appear under their names in the first row. The 2s tell us that the land planner and the project manager share responsibility for supervision of the task. The 3s indicate that the planning team must consult with the engineering manager, the operations manager, the logistics manager, the lead budget analyst, and the resource manager as they establish the project plan. You can also see who else they may need to consult with, the 4s, who must be notified, the 5s, and who has the responsibility for formal approval of the plan, in this case, the program manager. By using this tool, it becomes clear who has what responsibility for each task. It also helps to show where decision-making authority lies, and it can illuminate where there might be personnel constraints. For example, if we look at the operations manager, that individual must be consulted for almost every task in the project. Similarly, the resource manager is either responsible and supervising or must be consulted for every task. So making sure that those 2 key individuals have time available and allocated for the project tasks will be essential to keep the project on schedule. This linear responsibility chart uses 6 numeric responsibility codes. That's not a requirement. You might see fewer codes and letters or symbols to represent them, such as in the next example. Here's the beginning of a linear responsibility chart with a slightly different format. Again, you see the individuals and teams listed across the top, and the tasks from the WBS listed down the left side. In this case, only the sub-project or activity from the WBS is listed, and then there's an alphanumeric code from the WBS that corresponds to the task. So you would need to refer to the WBS to know what task A1 is specifically. You notice that there are different symbols for the responsibility codes. And again, we have a legend at the bottom that explains what the different symbols stand for. Looking at task A1, for example, the industrial engineer is responsible for the task with support from the project engineer, and the project manager must approve completion of the task. That wraps up the videos for today's lesson. As a review, we introduced the solution implementation phase of the SDP and the tasks involved in it. We discussed the importance of test and evaluation, and we discussed ethical considerations in project management. And finally, we discussed the planning task of solution implementation and focused on 2 of the tools available for this task, the work breakdown structure and the linear responsibility chart. We look forward to the synchronous sessions with you all.